Okay, let's try this last question. I put the red lines in there again because I want to be careful because I asked this question at the end, and this one really throws people sometimes. It says, what for what values of x will g of x multiplied by f of x be a positive number greater than 0? And you have to be real careful going through it. But let's stop right here. See this red line right here? I'd like to pass it right through and talk about it, but I can't. I want to stop it right here. Now, there's two things I can see. I can see that g, the line at minus x plus 2, is greater than the parabola x plus minus x plus 2 times x minus 2. There's the parabola f. I can see g is greater than it. But I can also see that if g is a positive number, see, there's the y-axis, there's 0 right there, y and x, there's the origin. So it's negative here. A positive times a negative, that would never be greater than 0. So all the way to the left of b, it's just not going to work. It's just not going to work. And it won't work right at b too, because it'll equal 0. It won't be greater than 0. So it won't work right exactly there. Let's look at this next line here. Well, now look, it looks like f, the parabola, is greater than g. But it also looks, if I multiply these two together, the f value, hey, it would satisfy this. So bigger than a, it's working for this g times f. In fact, it keeps working all the way to here where it equals 0 again. And then on the other side, look, they're both negative. But here, g is greater than f. G is greater than f. But when I multiply them, I get a number that's greater than it. So it works here, it works here. It doesn't work here where they're equal to each other because it equals 0. It equals 0. And, oh, you know, it would work right here, wouldn't it? It would work here. I think I said it wouldn't work here. It doesn't equal 0 here, but this value, they're both positive, so it would be greater than 0. Okay, in fact, you see, if I go back here, I think I said something funny there because when it hits there, they're equal to each other, but they're both positive numbers and they would be greater than 0. Okay, let's get rid of these red lines. Now we'll try. Where is f greater than g? Well, it's in between this value of c, between 2 and between a. What's a? It's minus 1 here. So, hey, that means less than 2 or greater than minus 1. That's where f will be agreed. See, the snow's falling on top here, in between here. When do they equal each other? Well, at a, at minus 1, and when c is 2. That's it. X equals minus 1 or 2. When does g fall below? Oh, in that same interval right there. In the same interval, but less than or equal to. So that's it. When is g above? On the ends. So when it's less than or equal to minus 1 or greater than or equal to this 2 value, that's a 2 and 0. Okay, now here's the part that's a little bit tricky. When do we multiply them and get a positive number? Well, it doesn't work until you get to here. It equals 0. Now anywhere to the right of negative 2. It's working, it's working, it's working. In fact, positive times positive, positive, it's working. Oh, it doesn't work at c. So it doesn't work at minus 2. But now they're both negative. They're both negative as we go to the right here. So it works everywhere greater than minus 2, but not equal to 2. That's a fast way of saying it. You can describe this sets in other ways, but anywhere greater than minus 2, as long as x doesn't equal 2. That's a fast way of getting the set and getting the answer.